Well, that sharp jump in that preceding graph shows you, even though my graph doesn't make it look like it's discontinuous, but does show you a problem in the continuity at the point 0, 0. Another question that would arise would be, what is the criteria for a function to be continuous at a point in R squared? That's a domain point in R squared. The following definition covers that, I hope, if you're ready for it.
I'm so ready.
I'm glad to hear that. So, continuity of a function of two variables. A function f of xy is continuous at the point x sub 0, y sub 0 in an open region R. Open means it doesn't contain its boundary. If the limit as xy approaches the point x sub 0, y sub 0 of f of xy is equal to f of x sub 0, f of x sub 0, y sub 0. And that means it doesn't matter what path, we get the same limit. So that would bar this kind of a problem. And did we have another one earlier? Yeah, that would bar this kind of a problem also, because it wouldn't matter what path, it would just be equal to f of xy. I mean f of x sub y, f of x sub 0, y sub 0, if xy is approaching x sub 0, y sub 0. And we wouldn't have that issue of multiple limits. So a function is continuous on an entire open region if it's continuous at every point in that region. Sometimes you would say at every interior point of R. Interior meaning not the boundary. So here's an example of a function that's continuous on any subset of R squared, and it's just a trig function, f of x equals sine of x plus y. Well, most trig functions, sine and cosine in particular, are known to be generally continuous functions. I wouldn't say the same about tangent because it's got asymptotes, but I would say that about sine and cosine. And actually all the other ones too, tangent, cosecant, and secant, and cotangent alike, are continuous on their domain, but they have points of discontinuity that aren't in the domain. So now I could probably make a sine or cosine function that was discontinuous. For example, if I said, what about f of xy equals 1 over x plus y, then I'd have sine of 1 over 0 at the point 0, 0, so I'd have a point of discontinuity there. But this should be continuous everywhere on any subset of R squared. And it's just like a wavy line, that's all it is. Right? That's the graph.